right, hi everyone. My name is William Morgan, and this is the Intro to Linkerd talk, KubeCon EU 2020 virtual. I've given this talk a bunch of times at previous KubeCons, but I've never given the virtual version, so we'll see how it goes. This is an introductory talk about Linkerd. I am going to keep it up to date with the latest information. So if you are familiar with Linkerd, hopefully you'll still learn something in this. And if you're not, if you are still struggling with the concept of what is a service mesh, then don't worry, you're not alone, and I'll try my best to address those questions as well. Before I get started, just a couple things I wanted to say. The first is that Linkerd is a community project, and that's a big part of everything that we do. So, by virtue of watching this talk, you are just as much a part of the Linkerd community as I am. So I'm using all of my powers invested in me as Linkerd, maintainer or whatever, to now bless you with the ability to run Linkerd yourself, to talk about it, to understand it, and to join us. We have a very active community on Slack and GitHub. And in fact, these slides that I'm going to be presenting are also available to you. They're on, if you go to linkerd.io, you will see them in the community section. So if you want to give talks about Linkerd yourself, all of this material is available to you. Okay, so let's talk about Linkerd. So Linkerd is a service mesh, and I'll explain exactly what that means in another slide or two. Linkerd is an ultralight, ultra-fast, security-first service mesh for Kubernetes. I'll describe all of exactly what that means over the next couple slides. Linkerd was actually the very first service mesh project. It was the one that introduced the term service mesh to the world, which, honestly, we kind of regret at this point. But that's where we are. And as such, we've been in production for almost 4 years at this point, and a very healthy community of folks just like yourself, centered in the Slack channel and the GitHub repo. A lot of contributors. We have weekly edge releases if you want to try the latest and greatest features. Stable releases probably every 2 to 3 months. And Linkerd is committed to open governance, and of course it's hosted by the CNCF, so it has a neutral home. So we do our best to make this a full-fledged open source project. And of course, very many adopters in production use cases around the world, which we feel very fortunate to have. So, okay, let's talk about what Linkerd actually does. So Linkerd, like almost every service mesh, provides a bunch of features to you, right? And we kind of put these into 3 basic buckets. There's a set of features that are around observability, there's a set of features that are around reliability, and then there's a set of features that are around security. And all of those features, there's a couple kind of identifying characteristics about them. The first is, from the Linkerd perspective, of course, we try and provide these to you in a very, very simple and lightweight package. And we focus on operational simplicity, especially. So our whole kind of goal in Linkerd is to reduce the amount of overhead, kind of mental overhead, that you as an operator of a service mesh have to have. Now, the interesting thing about these features, right, is that these are all things that we could accomplish in the application, right? Things like service level golden metrics, right? So Linkerd can monitor your success rate and your latency distribution and your request volume. You can draw service topologies and things like that based on metrics data, right? You can do that in the application, and that's kind of been, the standard approach. You can use an APM or something like that. But the value that Linkerd provides is it does this at the platform layer. So it doesn't matter what language the applications are written in, doesn't matter what frameworks they're using, doesn't matter what the developers do. What Linkerd can provide is a consistent and uniform layer of observability across all of your services, right? And it does that at the platform layer. Now, there's limits to that, of course, right? Like we treat the services as black boxes, basically. So we don't know what's going on inside. We can't tell you, oh, this loop is happening 200 times a second or anything like that. But we can give you the golden metrics, things like success rate and latency, that you as a platform owner really need. And again, we can do them uniformly. across the entire infrastructure. Same thing with the reliability features, things like retries and timeouts, right? Linkerd is not a complete solution to reliability. There's a lot more you have to do. But we can do retries at the platform level under certain conditions, and we can do them in a way that's uniform and that's well parameterized and so on. And security, of course, Linkerd is definitely not a full security solution. There's a whole lot to security, but we can provide mutual TLS in between pods automatically at the platform layer without developers having to do anything. And I'll talk a lot about that because there's a really interesting security angle. So overall, if you walk away with nothing, else from this talk, I want you to understand that the service mesh provides a set of features, and it provides them at the platform layer, which means that you as a platform owner, who is operating the Kubernetes kind of ecosystem for your developers, you're actually decoupled from what the developers do. So the developers are, maybe another way of saying it is that developers are then freed. They don't have to implement the TLS. You get to do it at the platform layer. Okay. And so why do you care? I think I started touching on this already in the previous slide, right? So, all those fancy features, right? Linkerd gives them to platform owners, right? The SREs, the architects, the folks who are adopting Kubernetes, right? We give them those kind of critical primitives that you need for operating a large cloud native application. And we give them to you in a way that has no developer involvement. I made these slides on Google Slides, and they looked a lot better before I exported them to PowerPoint. So you can imagine those things lining up visually. So another way of thinking about it maybe is that Linkerd is it's not so much it's a solution for technical problems, it's a solution for socio-technical problems. We want to decouple the developer and the platform side so that both sides have ownership and agency in their goals for what they need to do for their job. So maybe that's a little too philosophical. Okay, so how is Linkerd designed, right? There's a lot of different ways of building a service mesh, and Linkerd has a very particular philosophy for how we do this. So the first is it has to work. It has to just work when it comes out of the box. So as much as we can, and there's always asterisks in these statements. Right? There's always cases where we can't quite do this magically for you. But as much as we can, if you have a functioning Kubernetes application and you install Linkerd, application should continue functioning, right? We shouldn't break stuff, and you should be able to get there without having to do any configuration. So we try and get you, kind of basic service mesh functionality without you having to do any configuration. The next design principle for us is ultralight. So we want this to be the smallest, the lightest possible service mesh. We want you to spend the least resources on this, computational resources as you can. And then the next one is around simplicity. This is one that I think is really often underlooked in the service mesh world, right? It's not just about making the computers do crazy things. There's a human in there, possibly someone like you, who has to operate this thing, who has to understand it, who has to justify it to your peers, who has to defend it when people are saying, something broken. I think it's this service mesh you introduced, right? So we have to reduce that operational complexity in every possible way. And we've just asked you to adopt Kubernetes, which is a huge mound of APIs and so on. And we don't then want you to double the amount of complexity. And then finally, the final kind of real core goal for Linkerd is to be security first, right? So by default, everything should be, if not enhancing security, it should at least not be making things worse. And I'll talk a lot about that in the next couple of slides. So Linkerd has a control plane written in Go. We've got a data plane written in Rust, which I'll talk about shortly. There's a long history with 1.x going to 2.x and some lessons learned that I wrote an article on a year or two ago, which you're welcome to read. If you want some boring bedtime reading. Like almost every service mesh, Linkerd has a control plane and it has a data plane, right? And that data plane is these tiny little proxies, micro proxies in our case, that sit next to your application and that intercept the calls in between services. So when A talks to B, actually talks through two proxies, right? It talks to the proxy on A and the proxy on B. And because of that, because it's handling both the client and server side, Linkerd can do cool stuff. We can upgrade your HTTP 1 calls to HTTP 2 calls. We can initiate and terminate TLS. We can monitor things on both sides, and so on. And there are a couple of variations of this, but this is very similar to how most service meshes work. I want to talk briefly about the kind of data plane side of things. So Linkerd is a little unique in the service mesh world in that we do not use Envoy. Envoy is a CNCF project. It's a proxy. It's great, used widely in production. Linkerd uses something that's simply called Linkerd 2-proxy. As you can imagine, it's not a general purpose proxy like Envoy. You can't take it out and kind of run it outside of Linkerd. It's specifically designed for the service mesh use case, which actually is quite different from like the general purpose use case. So because we have this kind of dedicated proxy, we can accomplish a lot of what we want to do with Linkerd. We can have a security kind of foundation written in Rust, which allows us to sidestep a whole class of memory vulnerabilities that are often present in C and C++ applications. We can be super fast and super light, of course. We do have regular third-party security audits for the data plane, especially thanks to the CNCF. And it's built on this very modern asynchronous network stack, kind of the state-of-the-art networking in the Rust ecosystem, projects like Tokyo and Hyper and H2. And of course, like all of Linkerd, it's 100% open source and 100% awesome. And so if you are ever interested in learning what state-of-the-art Rust network programming looks like, please come and check out that repo, and we'd love to have you get involved. I mentioned we had a security audit, and they wrote some really, really nice things about us. No need to really go into the details, but it's up in the GitHub repo, so check it out if you are into that sort of thing. We had some benchmarks run. This is now about a year old, so there have been a couple different versions of Linkerd and Istio since then, and we're going to try and update this, but at least as of KubeCon EU last year, huge difference in performance, I think largely in part to the kind of micro proxy that we use. But of course, still more expensive than not using a service mesh at all, right? You're always going to pay a cost. So we want to minimize that cost. We want to give you the features, we want to maximize the features and minimize the cost, I guess. So if you search for Kinvoke benchmarks, you will get all of the gory details there. And then kind of the most recent set of content or set of features that we've been focusing on is this idea of multi-cluster communication. So Linkerd actually provides this kind of seamless, secure communication in between pods, right? So I mentioned that the moment that you install Linkerd, TLS is enabled in between meshed pods. At least if they're speaking HTTP, it's enabled automatically, and you don't have to do anything as part of that. Right? I think if we go back to our let me go back to the architecture diagram. You can see in there's actually this little thing called the certificate authority, which is going to issue certificates. It's going to send those to the proxies. The proxies know what to do with them. It's going to rotate them every 24 hours. They're going to be tied in terms of TLS identity to the Kubernetes service account of the pod itself. So we have this really nice kind of zero trust model where the pods themselves are enforcing security boundaries and both ensuring not just confidential, but also not just confidentiality, but also authenticity of the communication between them, right? And so with Linkerd 2.8, which was out last month, let me go back to the diagram here. We extend that same model to cross-cluster communication. So if you are ever in a world where you have to communicate between Kubernetes clusters, it's not as easy as it should be. And so the multi-cluster features in 2.8 kind of met a couple design goals. The first was we wanted to have a unified trust domain across all the clusters. What that means is we wanted the same kind of security, mutual TLS-based security primitives to extend to this communication, because that communication was actually going to be happening over the open internet, right? And we wanted to have, we needed to have that so that you could have heterogeneous clusters. So it doesn't matter whether the clusters are in different networks, different cloud providers, or on-prems or not. Everything should just work. But at the same time, separate failure domains. So unified trust domain, separate failure domain. So if one cluster goes down, that means that it doesn't require other clusters also going down. I guess I'll put it that way. And providing a uniform model for doing this communication in a way that's transparent to the application. So you as the application can make a call. If you're A and I want to talk to B, you make a call to B. And you are actually not exposed to whether that is a local service or a remote service. In fact, it composes with the traffic shifting functionality. So you can send a portion of your traffic to the local A and a portion to a remote A, or you can split traffic across two different remote versions, of B. And that's all done in a way that's transparent to the application. So super cool set of functionality there that I'm really happy about. Okay. So, it is, I don't like talking about other open source projects, but unfortunately this question comes up like all the time. So I always feel obligated to kind of address it head on, and, feel free to add questions and so on. I'll do my best to answer these in a way that is kind of honest and forthright. A lot of people these days, especially, come to Linkerd from the Istio world. So their introduction to the service mesh was Istio, and now they're coming to Linkerd, and kind of want to know how these things compare and contrast. The way I like to think about this is it kind of comes down to what you need in a service mesh. And if you look at the themes of the two projects, and I'll try and characterize this in as gracious a way as possible, there's a lot of features in Istio, and Istio wants to accomplish a lot of things, and they want to accomplish it in a lot of different environments. Linkerd is kind of takes a very different focus, which is we actually want to do the bare minimum. We want to do the bare minimum that we think is necessary to build a secure, reliable, zero trust ready Kubernetes application. So our focus is on being as small and as lightweight as possible and giving you just a bare minimum features and the bare minimum kind of complexity that we can get away with while still accomplishing that goal. We also focus very heavily on Kubernetes. So it is currently not even possible to really run Linkerd outside of Kubernetes. You can obviously make calls, to non-Kubernetes resources. Like that's a fact of life for for almost all of us, unless we're in very new greenfield environments. That also means that we have a much more focused feature set. So we really try and do just the things that the bare minimum to get away with accomplishing that goal. So like I said, happy to answer more questions about that. Both great projects. Okay, and that's really kind of the end of this introductory session. There's a lot more material on linkerd.io. We've got a huge number of documents, docs and tutorials and blog posts. And there's like I said, a thriving community of us in the slack.linkerd.io. You can hop in there and ask people, any time of day or night, there's someone in there. Probably someone in there ready to help you out. We do have a set of mailing lists where we do kind of formal announcements. We have monthly community calls. Actually, the one this month is happening. By the time you see this, it will have already happened, but the August one will be happening kind of last Wednesday of August, and formal third-party security audits. So we have a really friendly, welcoming community. That's one of the things that I'm really proud of, and that people always point out when they come and ask us questions. So please get involved. And like I said, I want you to consider yourself a member of the community just as much as I am. This is a community project. It's hosted by the CNCF, and it is a service mesh that's for everyone. So thank you very much. Again, my name was William Morgan, and please ask me some questions. All right. Cool. Well, now you are getting the live William. You can tell because the live William has a hat. Okay, it looks like we got about 10 minutes for questions, which is great. And I see a whole bunch of questions in here. I'm going to answer the ones that pop out at me as I go through this, but afterwards I'm going to be hanging out in the Slack, the CNCF Slack. There's a 2-kubecon-maintainers Slack room. So feel free to join me there, and I'll continue this conversation even after the official Q&A period is over. So let me go through and answer a couple of these questions. So first, thanks for joining me for this. I know the virtual format's like a little funny, but I'll do my best. Okay, so Alec asks, if the need arises to change from one service mesh to another, Do you need to rewrite everything, or can you convert or migrate easily? I think it's a really good question. The answer is a little different for different service meshes. I think for better or for worse, it's easy to rip Linkerd out, because kind of the whole point of Linkerd is that we do all this stuff without you having to change your application. So certainly from the code change perspective, you can pull it out and you shouldn't have to change anything beyond that. I'm hoping that once you do that, you'll realize, oh my gosh, all the TLS and load balancing, whatever, is actually making things really good for us. But I'd say generally speaking, the point of a service mesh is to be kind of decoupled from the application. So hopefully it shouldn't be too hard to move from one to the other. So Alec, hopefully that answers your question. Martin asks a really good one. He asks, what are commonly requested features that Linkerd does not have plans to implement, that doesn't have or doesn't have plans to implement? So that's great. I'd say one common set of features we get asked for are things that belong on ingress. So Linkerd does not ship with an ingress layer. We instead ask you to install one of the 700 different great ingress projects. So things like I saw there was another question around OIDC Connect and things like that. Those are all handled at ingress. And I don't want Linkerd to do ingress. There's already so many good projects for doing that. So that's one common example. We actually resisted distributed tracing for a long time, because I was like, this doesn't really fit into the service mesh. You can't do distributed tracing in a way that involves no code changes. But eventually we gave up and implemented that. So I guess if you ask for something enough times, eventually we'll give up. Martin, those are two examples for you. Thanks for that question. Rafael, you asked about OIDC Connect, so no, we don't support that, and we don't plan to do that. Should be handled at the ingress layer. Okay, so let's see. I'm going to run through some of these other questions here. Alejandro asks, how can someone write integrations for Linkerd 2-proxy? Are you planning on providing proxy WASM filter support? That's a really good question. Yeah, so Linkerd 1.x, I didn't really talk about this too much in this intro session, but the original version of Linkerd was on the JVM. The JVM was horrible in a lot of ways, but one thing it gave us, which was awesome, was it had a really nice plugin model. So we kind of lost that when we re-implemented things in Rust. So if you want to do a data plane proxy in a compiled language like Rust, something like WASM starts looking really, really, really appealing. So yeah, I would say tentatively, that's the way we would do it. And ideally, we would do it in a way where we can make use of the same WASM, proxy plugins that the rest of the world is using. So right now, that's not in Linkerd 2 proxy, but it is on the roadmap. And if you want to get involved in the very cool intersection of Rust and WASM and service meshes, then please hop into the repo and let's work on something cool together. Okay, so let's take a look here. Will Spiffy be taken on in the near future? This is a question from Rio. Will Spiffy be taken on in the near future for the identity system with their SVIDs? We've been looking at the Spiffy project. So far, it hasn't been compelling enough to really bite the bullet and implement it the way we've done identity, in Linkerd with all the MTLS stuff so far, as we tie it to service accounts. And we've avoided, I think, a lot of the problems that Spiffy solves by not having a great mesh expansion story. So, we've kind of avoided it so far, but I'd say generally speaking, it's something that we are aware of and, probably will be a topic of discussion. So thank you for that question, Rio. Yeah, it's a very interesting question from Vim, who asks, can Linkerd also communicate with other service meshes? Well, I mean, yeah, it's all network calls. So you could run, Linkerd on one cluster and Istio on another, and, something else on a third, and, they're all talking to each other. So I guess at the basic level, yes, you won't have the MTLS stuff working probably in a really unified way. Like you'll have to treat this as like the cross cluster communication will have to be done like through ingress or something. I don't know. You'd have to treat these all, I guess, as like external, as like separate clusters, which is a little different from like, if you're running Linkerd multi-cluster. But yes, at its heart, you can communicate with other service meshes. The cluster boundary is kind of like, the level of granularity you have. Okay, so thank you for that question. Okay, let's see what else is in here. Oh, you folks have asked some really great questions. Rio asks, will MTLS for TCP be supported? Yes, that's the headline feature in the 2.9 release, which is the next release expected this year. So all of the fancy MTLS stuff that I talked about so far is on by default for HTTP traffic, gRPC traffic. But if you're doing something like Kafka or Postgres or something that's not HTTP, then currently we can't do MTLS until 2.9 chips, and then we should have that all sorted out. So thank you, Rio, for that question. Whew, all right, I'm running through these things. Okay, does Linkerd work in OpenShift v4? That's the question from Per. Probably. It should. There's no real dependencies that Linkerd has on anything beyond Kubernetes. Sometimes things like the way you have your security policies and stuff configured makes it harder to install Linkerd, but we have this command called Linkerd check -- pre. And if you run that, it will validate against the cluster kind of that it has everything that it needs. And that'll cover like 95% of the cases. So if you have a OpenShift v4 cluster out there, run Linkerd check -- pre against it, and it'll tell you exactly what will happen if you try and install Linkerd. All right, so thank you for that question. Let's see what else we have. How cumbersome, so Goran asks, how cumbersome or not is it to debug issues that may pop up inside of Linkerd? That's an excellent question. One of the first things that happens when you install a service mesh, if you ever do this in your own company, is that everyone starts blaming you whenever something goes wrong. Like, hey, who's this idiot who installed the service mesh? So we provide a bunch of tools for understanding the state of Linkerd, so that when the angry mob is outside your gate, asking you what's going on, you can actually defend yourself. So, the first thing is we've got tools like Linkerd check and so on. The dashboard, Linkerd dashboard itself, shows you exactly what's happening on the in the control plane, the status of everything. Actually, the control plane is running on the data plane, which means that the same tools we give you around metrics, observability, MTLS, and everything for your applications, actually, you can use those for the control plane itself. So we basically try and make it as easy as possible to understand the state of the Linkerd control plane, because that's a big part of the operational burden, right? You don't just install it and then you're like, okay, everything works. Right? Things do break, and you have to understand where that problem is. Is it somewhere in Kubernetes? Is it somewhere in Linkerd? Is it somewhere in the application? Mostly it's in the application. It's my or DNS. Okay, let's see. I think we probably have time for one or two more. So let's run through here. So Lefteris asks, looking at the Getting Started guide. Okay, so if you go to linkerd.io and click on Getting Started, there's a 5-step walkthrough. Do I need to manually attach Linkerd to each application, or do I just apply it to a current cluster and it works? Yeah, so the way it works is it's kind of a 2-step process. First, you install the control plane. Once you install the control plane, like nothing is happening besides, like it's sitting there. Then you mesh your application, right? And mesh means you add the data plane. And in order to do that, you can do that like one service at a time. You can even do it one pod at a time if you want. But that's what actually activates the service mesh for that application. So you have this way of doing things incrementally. So, you said manually. Is that manually? You can do it in a variety of ways. We use annotations and proxy auto injection stuff. You can read about it in the docs. But basically, you can do it in an incremental way. So hopefully that makes sense Left Terrace. Okay, sounds like we're basically out of time. We have to view a sponsor message at this point, so we'll take a little commercial break. But once again, I'll be on the Slack channel at 2-kubecon-maintainers, so please hit me up there. I'll be hanging out for the next 15-20 minutes. And thank you for attending the Linkerd intro talk. I really appreciate it.